Hey guys, today I'll be doing page 113, question number 8a. In this figure, mass 1 does not slide with respect to the surface when the horizontal force shown is applied. Determine the magnitude of the horizontal force and assume that there is no friction. So first of all, let's just look at the figure. And so here we see there's a force being applied from here. So that's causing the system to accelerate in this direction. And while the system is accelerating to the right, mass 2 is accelerating downwards since it's a hanging mass due to gravity. And since it's on a pulley, it'll actually be pulling mass 1 along with it, so mass 1 is going this direction too. So let's just look at the free body diagrams. So for mass 2, we have two forces acting on it, the force of tension and the force of gravity. So this force of tension is equal to this force of tension in mass 1. So mass 1 has the normal force, the force of gravity, and the force of tension. The normal force and the force of gravity, they actually cancel each other out, and that means there's no vertical acceleration. And so what this means is Ft, the force of tension, is the only force that's causing m1 to accelerate. For mass 3, we have three forces again. We have the normal force, the force of gravity, and the applied force. Again, the normal force and the force of gravity cancel each other out, and the applied force is the only force causing the box to accelerate in this direction. So, in the question it says that mass 1 does not slide with respect to the surface when the horizontal force shown is applied. So, with respect to the person, mass 1 is actually zipping across the room, but with respect to mass 3, mass 1 is not moving. This is only possible if mass 1 and mass 3 are both accelerating at the same rate. So we can use the relationship between their accelerations to find F applied. So acceleration horizontal of mass 3 equals the horizontal acceleration of mass 1. So we should already know that F equals ma, and we can rearrange this to A equals F over m. So for mass 3, the force is Fa, that's the only force that's being acting on it, and divide this by m. So since it's the entire system moving, it's actually sigma m, or the sum of all the m's, and that is equal to the force acting on mass 1, which is the force of tension, and that's divided by m1. So we can rearrange this to solve for the applied force Fa. So Fa is equal to the force of tension, which is, since the force of tension is the same for mass 2 and mass 1, we can plug in m2g, which is the force of tension, and that's divided by m1. All that's multiplied by the sum of the m's. So this is our formula, and all we have to do now is sub in the numbers. So F applied is equal to 1.2 kilograms times 9.81 meters per second squared divided by 1.8 kilograms, and that's multiplied by 1.2 kilograms plus 1.8 kilograms plus 3.0 kilograms. And just gotta plug this into your calculator, and you should get as your answer 39.24 newtons. And when you consider sig figs, it will round to 2 sig figs. So F applied equals 39 newtons. And we have solved this problem.